Thank you, Urmila. Thank you. Thank you. Well, good morning. Thank you all for coming this early in the morning. I know it was tough to some of you, to some others maybe not as tough, but thank you anyways for coming. Just overall, what we do at CDC, CDC is a U.S. company. The headquarters are in Dallas, Texas. These are the number of offices that we have in the U.S. and international. What we do is engineering, design, and consulting of building enclosure systems. CDC started 45 years ago, and the only thing that we did back then was curtain wall, hence the name. But throughout the years, we have incorporated different systems, and now we cover the entire enclosure system, including below-grade waterproofing and roof systems. So the topic for today is, does safety glass manufactured abroad meet U.S. building code? So we're going to go through the requirements that we have in the U.S. So we need to establish that first. We're going to review that. Then we're going to see some examples of where glass is manufactured abroad. And we then are going to explore if there's any equivalence regarding the code or standards. And then we're going to see if it does or if it does not. So first, we've seen a lot of materials outsourcing. There's different types of materials that are outsourced. Fasteners is one of them. Embed channels and inserts is another one. On this one in particular, I could talk hours, but this is not today's topic. Hardware has also been outsourced. Window hardware, door hardware, systems, but now with the tariffs on China goods, some of these systems that have been coming from China are now more expensive because of the tariffs. But today we're going to talk about glass. Now, why is glass outsourced? Well, first, one of the reasons is color. Not all colors are available in the US. Another one of the reasons is cost, and this is one of the main drivers. Specialty glass, not all specialty glass is available in the US, and size availability. Coatings, not all coatings are available in the US. Not all fabricators can laminate large pieces of glass, and fabrication of large insulated glazing units is also one of the drivers. So what are we asking for the glass to do? What do we need the glass to meet? Amongst other, it's energy, strength, impact, safety, bird-friendly, acoustics, flatness, fire, aesthetics, and the list goes on and on and on. Now, one of my colleagues noted that I have aesthetics on the bottom of the list. The reason is because I'm not an architect, I guess. Today, we're only going to focus on safety. So codes are focused on human life, and that is what we can say overall regarding the codes, right? And they are designed to preserve life of individuals or reduce injuries. Now, the following video I have played in other of my presentations. I even played it 4 years ago here at GPD. For those who are sensitive, or if you cried watching The Lion King or The Notebook, maybe don't watch this video. So look at this guy right there. So maybe this is a guy after today's party, and we are going to focus on that guy wearing the black shirt. That one. So look at him. I think he is what you would call drunk. And then he's flexing a little bit, and there he goes. But he survived. Now, I wouldn't be playing this video if he hadn't survived. Now, so again, it is important to remember that the codes focus on preserving life of individuals or reduce injuries. The code does not cover idiots like that, right? And natural selection kind of failed in that case, but he survived nevertheless. In the US, glass is one of the few materials that is regulated by the federal government, which means that whatever the code requires regarding glass, you must meet. Regardless of where your glass is being fabricated, you must meet these requirements. And this is regulated in the Consumer Product Safety Commission, by the Consumer Product Safety Commission under Title 16. This was first released in 1970, but when it was first released, it only addressed glass indoors and side panels. today, it has evolved a little bit, and it only covers now glass indoors. So that's that. Now, IBC, the International Building Code, regulates glass at other locations, and they have different, what it's called hazardous locations, and all of those are identified in the code. Now, the International Building Code, IBC, has been adopted statewide by the majority of the United States, except for Arizona, Delaware, Kansas, and Nevada. But remember, glass is regulated by the federal government. So regardless that, it doesn't matter that Arizona, Delaware, and Kansas, and Nevada feel special, you must meet those requirements. So IBC references CPSC, and it also references ANSI. So according to IBC, section 2406.4, it lists all the hazardous locations for glass. One of them is glass indoors, glass adjacent to doors, glass in windows, glass in guards, and railing. Again, I could talk hours about that. Glass adjacent to wet surfaces like saunas, spas, kind of like that. And the last one is glass next to stairways and ramps. Now, for this presentation, we are only going to cover glass in windows. And IBC 2406.3 has 4 criteria for glass in windows. And if you meet all 4, then you must have safety glass. One of them is if your exposed area is around 0.83 square meters. If the bottom edge is less than 18 inches from the walking surface, then like the example here, you see the photo there, the glass there is more than 18 inches from walking surface from the bottom. So in that case in particular, your glass does not have to be safety glass. The next one requirement is that the top edge of glass is greater than 36 inches, and the last one is that one or more walking surfaces are within 36 inches measured horizontally. So for this photo, this last one here, that one you must have safety glazing because it meets all these 4 criteria. Now, examples of glass manufactured abroad is what we're going to show here in this slide. And IBC 2406.3 says that safety glazing needs to be identified with the safety standard with which it complies. This is very important. Remember, in the IBC, there's only 2 standards that are referenced, ANSI and CPSC. So you must stamp your glass with those 2 standards. This is very, very important. This is one example. The glass that you see here is identified. It has the standard that it complies with. You see it there, CFR 1201, that's the Title 16, and it also complies with ANSI C97.1. This glass was manufactured outside the U.S. This glass was made by Tivitec in Spain. That one there is Technoglass, that's their template, and this is one example of their glass. That glass was manufactured in Colombia, also outside the U.S. Colombia as in South America. Some people in the U.S. say Colombia, Maryland, but no, this is the country. Right? And then this last one is manufactured by Crista Curva. Crista Curva, we have Crista Curva here present. Thank you for the images. And as you can see, Crista Curva also, they manufacture, well, they have 2 different factories. In Mexico is one of them, so they do comply with the building code. You can see there, it's tempered glass, it's stamped, and also something very important is that it needs to be permanent. So the glass bulk needs to be acid edge, permanent. You can't be able to erase, you shouldn't be able to erase it. IBC 2406.1, it says that glass must meet human impact loads. Not like the guy on the previous video. But check this one out. I don't think that the intent of the code is for that to be met, because in that example, in that video, the human didn't impact the glass. It's vice versa. The glass impacted the human. Again, it survived, otherwise I wouldn't be showing this. Now, 2406.2, it says that it needs to meet the prescribed impact test. And this section references CFR, also Title 16 and ANSI C97.1. Now, on the CPSC, which is Title 16, it lists and all the procedures on ANSI. And the language between the ANSI Z97.1 and Title 16 is very consistent, is very similar. They both have two different glass categories. And one, it's A and B for one of them, and the other one is class 1 and 2. And there's two different criteria, one for glass that is less than 0.83 square meters, and the other one is for glass that is over 0.83 square meters. Now, safety glazing testing in the US is, again, governed by this standard, ANSI Z97.1, and it's the impact test. Now, the impactor assembly, the mass, should weigh 45.4 kilograms. And for Class A, the drop height is 1.22 meters, between 1.2 and 1.23 meters, which is roughly 48 inches. Now, there's only one criteria, the pass-fail criteria for this standard, and it's that one that you see there. Now, something very important is that this is a little different from the standard that they have in Europe. But something to take away, and this is the second takeaway from this presentation, is that Section 4.4 of ANSI states that flat glass test methods are exactly the same as for bent glass. Very important, and keep that in mind. So what are we looking for? This is an example of the certification for glass manufactured outside the U.S. This certification that you see here was granted to Tecnoglass in Colombia. Now, there's two things that Colombia has given the world. Number one, Tecnoglass, and number two, Shakira, in case you didn't know. And Shakira is from Barranquilla. So that's the certification that they have. But this is for flat glass. Very important. Flat glass is, well, you need to comply with all the requirements. And bent glass has the exact same requirements for safety as flat glass. Don't forget that. The European standard that is comparable to ANSI is EN 12600. And it is there in that standard, it describes the same test method. The impactor assembly, however, it's a little heavier than the one in the US. The impactor assembly is 50 kilograms, roughly. And for class 1, the drop heights are 190 millimeters, 450, and 1200 millimeters. It has four different criteria for the pass and fail, and that's what you see there. But we're not going to cover that in detail. But something very important, very, very important, is that EN 12600 does not cover bent glass. It is just not included, period. So here is the comparison between one and the other. On the left, you see the requirements for Z97.1, and on the right, you see EN 12600. So we can say that both do have the same intent, right? The difference as well is that EN 12600 has different drop heights, and you need to do the 3 drop heights for each specimen. In the US, there's only 1 drop height. That's one of the basic differences. And again, bent glass is not covered by EN 12600. So what are the implications for that? Well, the glass bug for bent glass, if it's manufactured in Europe, cannot be stamped with that standard. It can't, because it's not covered, it's not existent. The differences between one and the other, this is the impactor in the US. This is the ANSI one. You see the shot back there. And the one here on the right-hand side is the twin tire for the EN 12600. Now, a very good source told me just recently that if you test the same specimen with one and the other, that one will make the glass fail. So although they are, the two standards are looking for the same, the intent is the same, that one, there's more chances for that one to make the glass fail over that one. But that would be the topic of a different presentation as well. And I have talked to my source, and my source said that there's interest about doing that presentation. Now, so the question remains, does safety glass manufactured outside the US meet the International Building Code. And again, we can establish a direct intent and comparison between the two standards. But the question is, does it? So glass manufactured outside the US and tested to the applicable standards can meet and be marked as required by the code in the US. And it has been. But again, this is flat glass. That TVTech, and it does meet the code, and it's marked according to the code requirements in the US. That one is Technoglass. Again, it does meet the code, and that's Crista Curva. The examples here are for flat glass. But not all bent glass meets the code requirements in the US. Now, there's an example here of a project in Washington, D.C. This is the City Center Hotel, designed by Herson and DeMure, with HKS as the architect of record. And as you can see, all of this glass is bent, all of it. And that's the stamp. So that glass, I don't know if it was manufactured in your Houston facility or your Mexico facility, but that bent glass does meet the US code. But again, not all bent glass does. So this other project, was designed by Shop Architects, and there was a need for 48 bent glass units. Those units are located here at the corners, but there were only 48 that were required. So during the submittal process, we requested the glass book. We needed to see what the glass mark was going to look like. So when we got it, we definitely said, well, this doesn't meet the code. And when we went back and forth with the fabricator, they said, well, we know, but we cannot mark it with, we cannot stamp it with EN 12600 because it's just not covered by that standard. So the question was, all right, well, so if we want to have this glass installed in a project in the US, you must meet the code. And they didn't have the testing available to be able to mark that glass, because they did have testing available for the same sizes, for flat glass sizes that you can draw a comparison depending on the glass makeup. You can use the flat glass testing, but they didn't have the testing per ANSI for that exact makeup. So the question then became, well, all right, then we need to do the testing to comply with ANSI and to be able to mark it with the requirements for the US code. But the owner was very adamant about that, well, you need to pay for the testing, right? I mean, they didn't have the testing. So it was a cost impact, it was a schedule impact. Again, the sizes weren't available. The curvature on all 48 were different. So there was only like 7 curvatures that were the same. So there was a lot of testing required for only 48 units. So what happened then was that we had to draw a comparison between one standard and the other, and we needed to make sure that the building officials bought into it. Because if you don't follow these steps, your glass can be rejected, and you might be asked to remove the glass from the project because it doesn't comply with the code. So because we didn't want that to happen, we went through the process of submitting paperwork, of submitting the testing that was available, of doing finite element analysis to prove that the glass that they wanted to use was fine for the application. So this is how the glass was stamped for the 48 units. It was made by Cricursa in Spain, but as you can see, it doesn't have any standard that because they couldn't stamp it with any standard. So that's what the glass book looks like. So to finalize, you have to keep in mind that major glazing manufacturers in Europe do meet EN 12600, but bent glass is not covered by that standard. Major glazing manufacturers can meet ANSI requirements, which it's then meeting the IBC requirements. Glass can only be marked with the standard that it was tested to. And almost all manufacturers can mark the glass as required in IBC for flat glass. Marking could become an issue for bent glass, so you have to pay a lot of attention. One of the architects on the project that I showed was questioning why were we making a big deal out of it. And the fact is that we weren't. We were just making sure that it complied with the code. And we were just paying attention to it. And the point that the architects were making was that this manufacturer has projects all over the U.S., and that there has never been an issue regarding what I presented today. But the thing is that if the fact is that if there hasn't been an issue, it's just because someone was not paying attention. So before you proceed with safety glass in the U.S., either to be installed, to be sold, or whatever, you have to make sure that your glass can be stamped as required by the International Building Code and that it meets the code. Yeah, because otherwise glass could be rejected after the installation, and that would be too expensive and too catastrophic. All right, well, that brings us to the end of the presentation. I don't know if you have any questions. Well, thank you then. Thank you very much.
Thank you very much, Vicente.
Hi there. Did you like what you just saw? If you did, why don't you like the video, drop us a comment below, and share the video as well, since GPD is all about sharing. And to receive more videos in future, subscribe to this channel and don't forget to click the bell icon. Ciao.